Permutation and combination, a topic of quantitative ability. Let us understand what is combination. Combination is denoted by NCR. What it means? It means the number of ways of selecting R items out of N items. Mathematically, NCR will be equal to N factorial divided by N minus R factorial into R factorial. Let us take one example to understand its application. 5 persons attend a meeting. If everyone shakes hand with everyone at the end of meeting, how many handshakes are possible? So to count one handshake, I need every time 2 persons out of the 5 persons. So number of ways of selecting every time 2 persons out of 5 persons is 5C2, which is equal to 5 factorial divided by 3 factorial into 2 factorial. And if I solve this, the answer comes out to be 10. So total 10 handshakes are possible if everybody shakes hand with everybody exactly once. Let us take another example. How many triangles can be formed by joining the vertices of a hexagon? A hexagon has 6 vertices. To form one triangle, I need any 3 vertices. For example, like this. This is the first triangle. As I choose randomly 3 vertices, or like this. So how many such triangles can be formed? To form one triangle, I need to choose any 3 vertices, and those combination of 3 vertices should be different for the next time. So the number of ways in which selection of 3 vertices can be done out of 6 is 6C3, which is equal to 6 factorial divided by 3 factorial into 3 factorial. And if we solve this, that comes out to be 20 triangles, 20 different triangles. Example 3. How many diagonals are there in a regular decagon? You can pause this video and try this question on the paper, and once you have solved it, you can resume it. Well, a decagon has total 10 sides and 10 vertices like this. So to make one diagonal or a straight line, I need to choose any 2 vertices at a time. So the number of ways in which I can select any 2 vertices or 2 points out of 10 can be given as 10C2. So what is 10C2? It is equal to 10 factorial divided by 8 factorial into 2 factorial. Now if we solve this, it comes out to be 45 lines. Well, but 45 is not the answer. So total 45 lines can be formed by joining 10 non-collinear points. Out of these 45 lines, 10 lines are the edges of the decagon. So minus 10 edges if I do, remaining are 35 lines, which are nothing but the diagonals. So the answer is 35. Example 4. From a group of 5 boys and 8 girls, 6 students are to be selected to form a committee such that there should be a majority of boys. In how many ways can it be done? Well, the number of ways will be something like this. I will select all 5 boys and 1 girl. This can be one way. Or let us say 4 boys and 2 girls. I cannot go with 3 boys and 3 girls because in the problem it is clearly mentioned that there should be majority of the boys. So one way can be 5 boys and 1 girl, and second combination can be 4 boys and 2 girls. Okay. Now how it can be mathematically written further? I am selecting all 5 boys out of 5 boys, which can be written as 5C5, and out of 8 girls I can select any one girl, so that can be written as 8C1. Further, out of 5 boys in this combination, I am taking any 4 boys, which can be written as 5C4, and out of 8 girls, I am selecting any 2 girls, which can be written as 8C2. One thing I will tell you, whenever the word and comes, you have to do multiplication, and whenever the word or comes, you have to do addition. Okay. Now, this can be further written as 5 factorial divided by 0 factorial into 5 factorial, and 8C1 is written as 8 factorial divided by 7 factorial into 1 factorial. Okay. So 5C4 is written like this and 8C2 is written like this. After solving this, it comes out to be total 148 different ways in which you can form a committee having majority of voice. Okay, after understanding the combination and application of the formula of NCR, now let us understand the possible different arrangement. There are three persons A, B, C which are standing in a row where A is to the extreme left, B is in the center and C is to the extreme right. The question is in how many ways these three persons can arrange themselves. Means the person in the left can go to the center, center person can go to the right, right person can come to the left, etc. So in how many ways these three persons can make different arrangement among themselves. Okay, the possible ways are like this. First way is ABC, which is already written there. Second is ACB, then BAC, BCA, CAB and CBA. So there are total 6 ways in which these three persons can arrange themselves. These are nothing but 3 factorial number of ways. As there are 3 persons standing in a row, the number of ways in which they can arrange themselves are 3 factorial ways, different ways. If there are 4 persons, it will be 4 factorial. If there are 5 persons, 5 factorial. If there are n persons, n factorial. If I ask you a question, in how many ways can 10 letters be sealed in 10 envelopes? Well, the answer is 10 factorial. These are the number of different arrangements possible. Okay, now let us understand what is permutation. It is denoted by NPR. What it means? It means the number of ways of selecting R items out of N and then R factorial different arrangements. So NPR is equal to NCR into R factorial. Well, NCR stands for combination. Number of ways of selecting R items out of N items and further doing R factorial different arrangement. So I will say that permutation is an extension of combination. In combination, we are only restricted to selection of R items out of N items. But यहाँ पर after selecting those R items out of N items, we are doing R factorial different arrangements also. So if we write this expression, that is NCR equal to N factorial divided by N minus R factorial into R factorial and multiplied by R factorial, the resulting mathematical expression for permutation will be N factorial divided by N minus R factorial. So simplifying this, when you have to do only selection, you will go for combination. But when you have to do selection and arrangement, you will apply the formula of permutation. Let us understand permutation with a simple example. In how many ways can 4 persons sit in a row of 6 chairs? Now here, out of the 6 chairs, first of all, they need to select any 4 chairs to sit. And from those 4 chairs, they can arrange themselves in total 4 factorial number of ways. So 6P4 will be equal to 6C4 multiplied by 4 factorial. 6C4 is required to select any 4 chairs out of 6 chairs. And out of the 4 selected chairs, the 4 persons can arrange themselves in 4 factorial ways. So it can be further solved like this. 6 factorial divided by 2 factorial into 4 factorial multiplied by 4 factorial. So solving this, the answer comes out to be 360 ways in which 4 persons can sit in a row of 6 chairs. Well, this question can be solved by another alternate method, shortcut method, which I will tell you. Now, when first person comes to sit, how many options are available in front of him? If first person want to occupy a chair, there are total 6 chairs available in front of him and he can select any one chair. So the first person has 6 options to sit. Now what about the second person? One chair already gone, taken by the first person. So second person के लिए the number of options available are 5. Now the third person comes, उसके लिए कितने chairs vacant है? He is having 4 options to select. And when the fourth person comes, now there are only 3 vacant chairs out of which he has to select any one. So there are 3 options left for the last person. So the total number of ways in which these persons can occupy the chair is 6 into 5 into 4 into 3, which comes out to be 360. Well, it's up to you which method you go for. Example number 6. How many 3-letter words can be formed such that each letter is distinct using vowels? Well, there are 5 vowels and I want to form a 3-letter word. So out of the 5 letters, I have to select any 3 letters and arrange them. So I will apply permutation, which is 5p3 equal to 5c3 into 3 factorial. And after solving this, the answer comes out to be 60 words. Well, same question can be also solved by shortcut method. When I want to select the first letter, how many options I am available with? I am available with 5 options. Out of 5 vowel, I can select any one vowel at the first place. So for the second letter, how many options are left with me? Now there are 4 options left with me because एक vowel already ले लिया, and in the question it is clearly mentioned that each letter should be distinct. So 4 options are available for the second letter, and now for the third letter 3 options are left. So total number of words that can be formed is 5 into 4 into 3, that is equal to 60. Same answer we will get. Example 7. How many 4-digit numbers can be formed using digits 0, 1, 2, 3, 4, 5 and 6 without repetition of digits such that the number is divisible by 5? Well, so we want to form here a 4-digit number and it should be divisible by 5. That is only possible if the unit digit is either 0 or 5. So let us take the unit digit here as 0. So 0 cannot appear anywhere else because it is clearly mentioned that there should not be any repetition of digits. Okay. Now this first digit can be selected in how many ways? Out of these digits available from 1 to 6, any one digit can come here. So there are 6 ways to select the first digit. 5 ways are there to select the second digit. 4 ways are there to select the third digit. So total 120 numbers can be formed, in which 0 will appear in the unit place. Another possibility is 4-digit number in which 5 will appear in the unit place. So I will write here 5. So first digit can be selected in how many ways? 5 cannot come here. Even 0 cannot come here, because if 0 comes here, it won't be a 4-digit number. So first digit can be selected in 5 ways. Second digit can be selected again 5 ways because 0 can appear here. And third digit can be selected in 4 ways. So total 100 numbers are there in which 5 will appear in the unit place. So 120 plus 100, total 220 numbers can be formed, 4-digit numbers can be formed, which are all divisible by 5. Total of all combinations. Out of the things, the number of ways of selecting one or more things is where we can select 1 or 2 or 3 and so on. Up to n things at a time can be given as NC1 plus NC2 plus NC3 up to NCN. See, when you want to select one item out of n items, it can be NC1. और मान लो n में से आपको 2 items select करना है, it can be NC2. और 3 items लेना है तो NC3 up to all n items, which is equal to 2 to the power of n minus 1. Let us understand this with an example. In how many ways can we select one or more out of the following 5 boxes? Now, when it comes to the first box, either we can select it or we can reject it. When it comes to the second box, either we can select it or we can reject it. So there are 2 options for every box, either to select or to reject. So total number of ways will be 2 into 2 into 2 into 2 into 2. That is 2 to the power of 5. So there are total 32 ways. -1. Now why we are doing -1? इसमें से एक combination ऐसा आएगा where we are rejecting all the 5 boxes. That combination we are subtracting, because यहाँ बोला है in how many ways can we select one or more boxes, means at least one box should get selected. Hence it is 2 to the power of 5 minus 1. Let us understand the next example where it is asked in how many ways can 5 letters be posted in 4 letter boxes. So like this, there are 5 letters, and to post every letter I am having 4 options available because there are 4 letter boxes. So first letter can be posted in 4 ways, second can be also posted in 4 ways, third can be also posted in 4 ways, and so on. So the total number of ways in which 5 letters can be posted is 4 to the power of 5. Let's go with another example where it is asked, if 8 different varieties of ice creams are available at the ice cream parlor, then the number of ways of selecting at least one of them. So like this, 8 varieties are there. To go with the first variety, we have two options, either to select or to reject. Second variety, again two options, either to select or to reject. So the total number of ways will be 2 into 2 into 2 for 8 times, that is 2 to the power of 8. Now in this 2 to the power of 8, there is one possibility that we are rejecting all 8 varieties of ice cream. And there is one possibility that we are selecting all 8 varieties of ice cream. Now in the question, it is clearly asked the number of ways of selecting at least one of them. So that one combination where we are selecting all 8 flavors, that we are subtracting. So the answer will be 2 to the power of 8 minus 1. ऐसा करने से the remaining number of ways are there in which at least one ice cream flavor is selected. Another variety of taking total of all combinations. The total number of ways in which selection can be made by taking some or all out of P plus Q plus R things, where P are alike of one kind, Q are alike of second kind, and R are alike of third kind, and so on. So the number of ways will be equal to P plus 1 multiplied by Q plus 1 multiplied by R plus 1 minus 1. Let us understand this with an example. On a carom board, there are 9 black coins, 9 white coins, and 1 red coin that are otherwise identical. In how many ways can we select one or more coin from them? Means यहाँ पर अपने को total of all combinations निकालना है. So we will apply this formula like this, where I will be doing 9 plus 1 multiplied by 9 plus 1 multiplied by 1 plus 1 minus 1. So that comes out to be total 199 combinations of selecting one or more coins. Now the next part is dividing into subgroups. In how many ways I can divide a big group into small subgroups. Suppose there are n things, which is the addition of P, Q and R. So if I want to divide a group of n things into 3 small subgroups of P, Q and R, I can do so in the number of ways, which is equal to n factorial divided by P factorial into Q factorial into R factorial. Let us understand this with an example. An auditorium has a capacity of 500 with ground floor 300 seats, first floor 150 seats and second floor 50 seats. In how many ways can the public be accommodated in the auditorium? Let us say a crowd of 500 is coming to the door of that auditorium, and we want to divert that public by splitting it in the group of 300, 150 and 50. How it can be done? The total number of ways will be equal to obviously 500 factorial divided by 300 factorial into 150 factorial into 50 factorial. This is a simple example of number of ways of dividing a big group into small subgroups. Next, subgroups are not equal. Suppose then the number of ways will be, as I discussed, it will be equal to P plus Q factorial divided by P factorial into Q factorial. Suppose subgroups are equal and distinct. Size equal है लेकिन distinct है. Then a group of 2P divided into two small subgroups of P and P, it will be equal to 2P factorial divided by P factorial into P factorial, that is P factorial square. And the third is subgroups are equal and identical. Then it will be equal to 2P factorial divided by P factorial square, and here we are multiplying it by 2 factorial. Why we are multiplying it by 2 factorial? Because the subgroups are equal and identical. Okay, let us understand this with another example. Rearrangement of the words. This part we have already seen, but let us see in a particular word, if the letters are identical, then how to find a number of ways. Example 13. How many different words can be formed by arranging the letters of the word car? We know that in the word car, all the three letters are distinct. So यहाँ पर जो subgroup का size है, that is one alphabet or one letter, and they are all distinct. So total number of ways will be obviously equal to 3 factorial divided by 1 factorial cube. As in denominator it is 1 factorial cube, which will be equal to 1. So we don't write it. It is 3 factorial. The second is time, which is a 4-letter word where all the letters are distinct. They are not identical. So obviously the number of ways in which arrangement can be done or total arrangements can be done is 4 factorial. Now we come to the word Titanic. Now in this word Titanic, if suppose this T and this T interchange their position and all other letters remain intact at their position, we won't say it is a separate arrangement. Or suppose this I and this I interchange their position and all other letters remain intact, we don't say that it's a separate arrangement. So यहाँ पर जो subgroups है, they are identical. There are 2 T's and 2 I's. Basically the word Titanic is a 7-letter word, but here the total number of arrangements won't be 7 factorial. It will be equal to 7 factorial divided by 2 factorial into 2 factorial. Why we are dividing by 2 factorial? Because 2 subgroups are identical. TT are identical and II are identical. Similarly, if we come to the next part, the word assistant. How many different words can be formed by rearranging the letters of the word assistant? It will be equal to 9 factorial divided by 3 factorial into 2 factorial into 2 factorial, because there are 3 S, hence 3 factorial. There are 2 T's, hence 2 factorial, and there are 2 A's, hence 2 factorial. I hope you understood how to do rearrangement of the words. Let us try out some examples of rearrangement of words. How many different words can be formed using the letters of the word urgent that begin with U and end with T? So we know that this word urgent is a 6-letter word like this, where the beginning letter should be always U and the ending letter should be always T. So it is fixed here. Now remaining 4 letters can be arranged in between 4 places in a total of 4 factorial ways. So total number of words that can be formed are 4 factorial. There are 24 words. Next example, where it is asked to find the number of words that can be formed using all the letters of the word project such that they start with R but never end with P. I request you to pause this video and try the question on the paper, and once you have solved it, you can again resume the video to look for the solution. Okay. Now again, this word project is a 7-letter word. We have to first locate these 7 places here, and we want that they should start with R but never end with P. Starting with R, how many words can be formed? So first letter is fixed. Remaining 6 letters can be arranged in these 6 places in a total of 6 factorial ways. Now, if first letter R is fixed and let us say last letter is P, then in between 5 letters can be arranged in a total of 5 factorial ways. So the number of words starting with R are 6 factorial, and the number of words which are starting with R and ending with P are 5 factorial. But what we want here, we want that the number of words which are starting with R but never ending with P. So that will be equal to 6 factorial minus 5 factorial, that is equal to 600 words. Another example, in how many ways can the letters of the word article be arranged in a row such that vowels are always together? Now in this word article, how many vowels are there? A is a vowel, I is a vowel and E is a vowel. We want that these three vowels should be always together when we are doing the rearrangement of alphabets. So what I will do, I will club these three vowels and consider them as one single unit like this: A, I and E. And these remaining four are consonants. So how many units are there altogether? There are now total 5 units. I will consider these three vowels as one single unit. Now these 5 units can be rearranged in a total of 5 factorial ways. And these three vowels can be arranged among themselves in a total of 3 factorial ways. So the total number of ways will be 5 factorial multiplied by 3 factorial, that is equal to 720 words. Next example. In how many different ways can the letters of the word optical be arranged in a row so that vowel never come together? So in this word optical, how many vowels are there? O is a vowel, I is a vowel and A is a vowel. We want that this vowel should be always separated. There should be at least one consonant between these vowels. Okay. Now when it comes to consonant, there are 4 consonants P, T, C and L. These 4 consonants can be arranged in a total of 4 factorial ways. Now the blank spaces, if I see where vowels can be placed, is 1, 2, 3, 4 and 5. So there are 5 blank spaces available where these 3 vowels can be arranged. So out of these 5 places, I have to select any 3 places and I have to arrange their 3 vowels, which can be done in 5 P3 ways. So these 4 consonant P, T, C, L can be arranged in 4 factorial ways, while these 3 vowels O, I and A can be arranged in 5 P3 ways. Why 5 P3? Because out of 5 places, as I shown you here, I have to select any 3 places, which can be done in 5 C3 ways, and out of the selected 3 places, 3 vowels can be arranged in 3 factorial ways. Hence selection and arrangement, that's why permutation, 5 P3. So the total number of ways will be 4 factorial multiplied by 5 P3, that is equal to 1440 words. Now let us summarize what we have learned. The number of combinations of n dissimilar things taken R at a time is NCR. The number of permutations of n dissimilar things taken R at a time is NPR. The number of permutations of n dissimilar things taken all at a time is NPN, or so called n factorial. The number of ways of arranging n distinct items in a row, of which P of them are alike of one kind, Q of them are alike of another kind, and R of them are alike of third kind, and rest are all distinct, then it will be equal to n factorial divided by P factorial into Q factorial into R factorial. The number of ways of selecting one or more items from n given items will be equal to 2 to the power of n minus 1. Now suppose if there is a big group of A plus B plus C things and we want to arrange it into or split it into 3 small subgroups, which can be done in A plus B plus C factorial divided by A factorial into B factorial into C factorial. The total number of ways in which selection can be made by taking some or all out of P plus Q plus R things, where P are of one kind, Q are of second kind, and so on, will be equal to P plus 1 into Q plus 1 into R plus 1 minus 1. So with this, we have understood the concept of permutation and combination. I request you to practice some additional questions from any of the aptitude book. Thank you for watching this video.